Hello everyone. In this presentation, I'm going to be explaining the process behind parametrically modeling this building with Grasshopper. I'll start with the columns. Both were created with the same procedure, but were done individually since one is slightly larger than the other. Starting off with the slightly larger column, the first step was to create the curves. I needed 3 curves. The base curve and the upper curves were created with the ellipse component using the same sliders. The only difference was that the upper ellipse was 2 times its size. The middle curve was created using the tween component, and it was also scaled so that it would better conform to the shape of the column. The next step was to use the lofted surface between those curves to give me the contours that would be extruded. So the second column was created in a very similar way. The only difference was that I had to translate the lower and upper curves first. I had to translate them in the y direction away from the origin where they were created, and I had to scale both the middle and the upper curves to give me this result. Moving on to the top form, the curves were created with the same process. The bottom curve was made into a surface, and the lofted surface between these 3 curves gave me these contours, which I needed to create the paneling, the piping, and the windows. Since the panels and the pipes are segmented and are not apparent throughout the entirety of the form, the contours had to be divided according to those segments. I divided the contours into 8 segments, and I needed the panels to be between these 2. So I used the interpolate data to give me a series of linear points between those 2. And I needed those points to conform to the contours, so I used the curve closest point. I then needed to move this geometry to these points, so I used the pufferfish component move to point to give me this. I then shattered the contours so that I'd be able to manipulate which parts I wanted to be piped. In this case, this side was to be piped together, leaving this segment to be piped individually. Since this was supposed to be a window, I first divided the curves into 2 segments and used the lines between those points to give me these pipes, and I also created a lofted surface between them. In order to create the roof frame and the domes, the initial curve was made with the metaball component, and these points were found with the curve closest point to the center. The same points were used to shatter this curve, and the lines between those points were used to mirror. The metaball curve was offsetted outwards and was extruded, while the joined mirrored curves was offsetted inwards and was extruded as well. All of the domes were created using the Kangaroo plugin. I'll explain the process for one of the domes. So a mesh was created using a rectangular plane that was constructed from the horizontal frames, and this is to ensure that the mesh lies within the same direction as this curve. Then, using the naked vertices component, I needed to anchor the naked vertices of this curve using the curve closest point, and I needed the load to be applied to the closed points. Then, after plugging them into the bouncy solver, this was the result. This is the final form, and this concludes my presentation. Thank you for listening.